they won't really be going into it. And again, that kind of comes from the statement. I don't know, have I been sharing the statement or not? If it's up on the screen.
It's now on the screen.
Okay, it's on the screen. So, yeah, my voice is a little bit hoarse today, but this is the transcript of what said. So this is one of the questions that shareholders were able to vote on that fortunately made it in there. And I'd say Elon spent maybe more time answering this question personally than some others. There may be another one or two in there that he did, but there were others he deferred to have his management team answer. And this one he took on himself, and he spent about 4 minutes on it. So the question is, how many Optimus bots have been made, and when will they be able to start performing useful tasks? So, and this was kind of funny, is Elon didn't give us a straight answer on how many there are. He's like, I think we're around 5 or 6 bots. We're at 10. Okay, so it was like, first it was like, I was crestfallen. I was like, what, single digits? And then like, at least get to the 10. I guess, and the reason why he's saying is, depends upon how many are working and what phase. That's understandable. Maybe they have enough parts for a dozen or so, but they're always in a state of disassembly or being tested or something like that. So maybe if you were to go down there and say, I want to see a demo of the Tesla bots, and it's like they can only get maybe 5 or 6 walking around at a time. The others are just overdoing whatever. So that's kind of where they are right now. I was hoping they'd have maybe 1 or 2 dozen, but it might make sense because when they, and then he says, but there's more every month, so that we know they're making at least 1 more every month. So, and next month we can say there's 11. In September we'd say there's 12. All right. And then he mentioned something that we've heard before, but you'd have to be paying really close attention to this stuff. But we've known about this. There's a lot of interesting things about the Optimus bot. We found there are actually no suppliers that can produce the actuators. There are no off-the-shelf actuators that work well for humanoid robots at any price. And then as Elon said it, suddenly you heard someone say something in the background. I didn't know who it was at first, which is why I looked for the transcript. Certainly not compelling. So the point is that you cannot produce an off-the-shelf, a robot with off-the-shelf actuators that would be compelling. The actuators just don't fit the bill the way they are. And they seriously looked at this problem. And so this is Lars's way of saying Optimus is actually compelling. It's the logic looks a little bit backwards here, but it's like, it's a double negative in there sort of somehow that he thinks Optimus is a compelling bot because they're designing it with the Tesla designed actuators. And remember, he is the internal user. Lars, he is vehicle engineering. He has nothing to do with robotics. So vehicle engineering is also going to include sort of the aspects of the manufacturing, because that's just how Tesla works. You just don't have, you design a car and then let these guys over here figure out how to build it. It's like, no, how you build it is part of the vehicle engineering, and then looking at those processes. So Lars is convinced that this bot is going to do the job for him. So he's definitely happy. Otherwise, he wouldn't have made a statement like that, which is why I wanted to pin down who said that. And then, yes, there are no humanoid robots that can do things that humans can do. So we're actually had to design our own actuators that integrate the motor or the power electronics, the controller, the sensors. So what he's pretty much talking about is like, yeah, you can go out and buy a motor and you can buy like a control board, you can buy some sensors and stuff like that, but that's just not how it has to be. It all has to be integrated in, and it has to have the right power package that you need as far as like the torque curves and everything else. They want to make sure you're not consuming too much energy or anything else along the way. So they have to make sure they optimize everything. And there was a famous screen sort of showing that I can sort of bring up. Maybe I'll try to bring that one up. You might remember there was a slide back in AI Day 2 that showed the 6 different actuators that they have. And the curves that were there. So, and I'll just kind of zoom in a little bit here. I've got this in the power. So this is a PowerPoint I put together to figure out how much the Tesla bot's going to weigh to verify that it meets what they say it's going to weigh about 120 pounds. And I wanted to verify and validate. Actually, what I wanted to do was find out how strong it was. Because remember, in the Investor Day video, they showed the Tesla bot carrying an arm over to the other bot. And at one point, it actually kind of put its arm straight out, holding the other arm. I'm like, oh, how much is that payload? How strong is it? What's it able to do? And so I was really more curious, like, how much does the limb weigh? And get an idea of that. And the only way to get an idea of that is to look at the servos that make it up and count up the mass from that. And fortunately, right here, these are the 6 custom actuators that Tesla has come up with.
Uh-huh.
And they gave the weight right there. So by having that weight, it was a lot easier for me to be able to figure that
Yeah.
out. Now, what they did is they did a series of simulations of all sorts of different tasks that a human or the bot would have to do, squatting, lifting, walking, whatever they were. And from it, they get an idea of how much torque was sort of required a particular joint to do that. And based on all those things, they get sort of an idea of the performance requirements, and they try to optimize it. And by doing that, they realize that certain joints have such a similar torque profile, they can be the same motors. So the idea is they did, because they have a total of 40 actuators that build it, but they don't have 40 different SKUs. The idea is to try to reduce that number. So up here in the shoulder, you have 3 actuators up here, but they're all the green actuator. They're all the same actuator. And then you see those same ones show up down here as well. So you've got 3, 3, 3. So 9 of that 40 is right there. Now, there's also the structural actuators, and then there's ones in the hands. So with the hands, you've got 12 there. So that's really 28 structural actuators. Then you go through here and you'll see some others like, you can't tell here, but there's a servo here and there's one right behind it. So there's actually 2 purples in each leg because you've got, the hamstring and the quad, right? one for the knee, one for, so those are both there. So that you need actually 4 of these in total. And you see some of this, more brighter green here for a longer wrist. And that one is kind of unique. It's like, darn it, we had to come up with an actuator just for that, just to take the hand to do that. Okay, well, that's what you have to do. And the yellow. But, they sort of found that we were required to put some of these in some cases, we could use them multiple times. Like right here, the elbow is red. And then down here at the ankle, you have 2 here. So they had to find the mix. And you'll notice it's a mix, when I go back, of rotary and linear drives. Because they found in some cases, you were trying to take a rotation and convert it into a linear motion anyway. And there's a bot from Fourier in China that Herbert and I took a look at a few weeks ago. That has some similarities to Tesla bot, but all the actuators are rotary. And when they get down to the hamstring, they have like a motor that's about that big. It's huge.
Wow. Okay.
And then all they're doing is they have a connecting rod on it. So, the reason for having a rotary robot is if or motor is that if it's right at the joint, it makes sense. But in many cases, you're not putting at the elbow a joint. The elbow is an idler, and the motor might be back here. And so what they do sometimes is they take a rotary motor and they stick a linkage mechanism on it to make it move. It's like, well, wait a minute. If you're taking a rotation, try to make it linear, why don't you just go linear all the way? And so that's what Tesla has decided to do, is in those places. So the Tesla leg is more compact than the others, because if you look at that other one, it's quite the package they got to put there, because they realize, like everyone else, your hamstring needs a lot of power. Your quadriceps need a lot of power to be able to walk and do what you want. So they're putting it in a more compact package. And again, one of the things that Elon sort of stressed is that he used the term lighter and tighter. So if I kind of finish his quote, which is out here somewhere, that, part of the design was not just that they were lighter and tighter, but they could actually be manufactured. So again, the Tesla philosophy, make sure we can actually build these things and make them function. So here is
his lengthy reply.
Right. So, okay. So then we talk about, right here. And then, of course, we'll be using the same inference hardware as the car, meaning that, the brain of the bot. But we were designing these actuators, designing them for volume production. That's very important. And it's not just Elon saying that. That's been said by many people within the team, going all the way back to AI Day 2, of how we set it up for volume, what we have to do. We don't make it out of titanium because it's going to be too costly. We want to make sure it's easy to produce everything. So they're not just lighter and tighter and more capable than any other actuators wherever they exist in the world, but it's also actually manufacturable. So we'll be able to make them in volume. Okay, so that's very important. Now, this next statement here might be kind of key why we aren't already seeing 100 bots or 200 bots out there, and why it's kind of a small number. The first Optimus that will have all of the Tesla-designed actuators, sort of production candidate actuators, integrated and walking around, should be around November-ish. So when I first heard that, I was like, the first bot to have the Tesla-designed actuators, what do we see walking around? I thought those were the Tesla-designed actuators. they are the Tesla design actuators, but you'd say they're the version 0.9. They're the ones that it's built by a craftsman. It's not built on the production line. It's being built in the lab.
Yeah.
And remember, we need 40 of these for one bot. Yeah. And they're, trying to churn those things out is probably not that easy. And so they've got just the number of bots they probably think they need right now with the number of team members to make sure they're busy playing with a bot all day. Because obviously if you've got 100 bots and you don't have like people to play with them, it's like, what's the point of having 100 bots? So they have enough. I thought they might have a little bit more for the AI, just to get more and more training. But it may actually not make sense to have that large number right now if all the actuators are handcrafted. Because every time you build one of these actuators handcrafted, it probably has slightly different performance characteristics than the other. They're not identical.
Yeah.
And so what that means is that, no two bots are actually that identical. They're close, but there might be enough variance that it just becomes really hard to train them. And you want them to be the same, because one of the key things that we want to do is that once we teach a task to one bot, all the others can do it. But if the bots are really different, they have a very different kind of signature
that's true.
abilities, then suddenly it might be, wow, they don't work right. Now, you have to be able to deal with the fact that over time, the actuators are going to just change their characteristics in the bot, just from usage, just from temperature, just from everything else. But you want to probably keep it within kind of a narrow window that is manageable. And so they might be like, let's not really go crazy with the number of bots until we're able to spool up the production line for the actuators, which sounds like it's November-ish. So around then, they're going to start having it. And that's my prediction. November-ish is when we are going to have AI Day 3. Because they pushed the last one off, because the AI Day 2 was supposed to be end of August last year. And then it kind of got pushed off to the end of September. Why? Because they wanted to have something to show. So it's going to be the same thing. They're not going to say anything about, they didn't commit when it is. And once they see, if for some reason they get things going end of September, then we'll see it in October. But November-ish, something like that.